All right, introductory algebra homework day 9 starts out with some word problems that have to do with addition or subtraction of integers. Again, integers are positive and negative whole numbers. Abdul is riding in a bike race that goes through a valley and a nearby mountain range. The table gives the altitudes in feet above sea level for the 5 checkpoints in the race. Use the table to answer the questions. I'm going to move this up so we can see what the questions are. So, how much higher is checkpoint 4 than checkpoint 3? When you're finding higher or lower, you're finding the difference between the two values. Difference means you're going to subtract the two values, and when you subtract them in the order of the question. So, checkpoint 4 is 655. I'm going to subtract whatever checkpoint 3 is. So, checkpoint 3 is a negative 92. When you subtract a negative, you end up adding those two numbers together. 655 plus 92. And so, I hid my calculator. I'm going to grab my calculator. And if you do 655 plus 92, you get 747. So 747 feet higher. Just a note, since this says higher, you get a positive answer. If it says lower, you're going to get a negative answer here, but you're not going to put the negative on because of the word lower behind it. In this case, it's higher. We don't have to worry about it. Part B. The top of the hill rises 499 feet above checkpoint 2. So in this case, we're really starting at checkpoint 2, which is at negative 216, and then we're going to rise. So we're going to add 499 to that. So we have negative 216 plus 499. My signs are opposite. I end up subtracting and taking the sign of the larger one. 499 minus 216 gives me 283. It's going to be positive, so 283 feet is the altitude of the hill. I went from down here at negative 216, went up 499 from that point, and ended up at 283. The second one, the table gives a small company's profits in thousands of dollars over the last 4 quarters. A negative number indicates a loss. Use the table to answer the question. How much less profit was made in quarter 1 than in quarter 2? Again, I'm trying to find the difference between the two profits. So I'm going to subtract. Since it says less, I'm going to end up with a negative answer. Quarter 1 was at negative 25. I'm going to subtract quarter 2. Quarter 2 is at negative 351. Notice both of these have negatives in front. My rule, add and keep the sign. So I'm going to have negative 351 minus my 25 is negative 376. I add and keep the sign. Now, the negative just means that it's less or lower. So when I put my answer in, I'm just saying it's $376,000 less. I don't say negative 376 less. So make sure they are on those ones. If it's negative, don't put the sign on there, because if it says less or fewer or something like that, it's indicated here in your answer. Another company's profit was $470,000 more than that shown in quarter 4. Well, in quarter 4, we were at negative 152. Negative 152. I'm doing more than that, so I'm adding 470 to that. The rule is subtract and take the sign of the larger. 470 minus 152 is 318. It's going to be positive, so $318,000 is where we're at. The third one, the table gives the temperature in Fahrenheit in 5 cities at 6 a.m. on the same day. Using the table, answer the questions. By noon, the temperature in Buffalo had risen by 11 degrees Fahrenheit. What was the temperature there at noon? So the temperature at 6 a.m. was at negative 3. We're used to that. If the temperature goes up, it rises by 11 degrees. What's the temperature going to be? Again, my rule is to subtract and take the sign of the larger. So if you take 11 minus 3, you're going to end up at positive 8 degrees. Right? If I'm at negative 3 and I go up by 11, I'm now at positive 8. How much lower was the 6 a.m. temperature in Toronto than in Santa Fe? I'm finding the difference between my two temperatures. I'm going to subtract. Toronto was at negative 16. I'm going to subtract Santa Fe's, which was at 65. Again, both of these have negative signs in front. I end up adding, or if I use my calculator, negative 16 minus 65 gives me negative 81. Now the question wants to know how much lower. It was 81 degrees lower than, not negative 81 degrees lower. So in Toronto it was negative 16, Santa Fe was positive 65. 65 compared to negative 18, I dropped by 81 degrees. That was supposed to be a 16. There we go. So 65 down to a negative 16, I dropped by 81 degrees. Now we're doing the rules for integer multiplication and division. The rules for multiplication and division are different for the signs for the rules for adding and subtracting. When we multiply and divide, if my signs are the same, either they're both positive or both negative, I'm always going to get a positive answer. A negative times a negative gives me a positive. A positive times a positive gives me a positive. If my signs are opposite, and I have one positive and one negative, I'm always going to get a negative answer. So, positive divided by a negative is a negative, and then I just divide. 45 divided by 5 is 9. Negative times a negative. A negative times a negative is a positive. 6 times 5 is 30. Since it's positive, I don't need the sign in front. Number 5 on the top of the next page there says negative 5 times negative 7. A negative times a negative gives me a positive. 5 times 7 is 35. Negative 54 divided by 9. A negative divided by a positive is a negative. 54 divided by 9 is 6. Number 6 then. A negative divided by a negative. A negative divided by a negative is a positive. 27 divided by 9 is 3. 4 times negative 7. Positive times a negative is a negative. 4 times 7, 28. So it'll get confusing for those who aren't real familiar with those rules, because when we add and subtract, if my signs are the same, you keep the sign, and if they're opposites, you take the sign of the larger. But when you multiply and divide, if they're the same, it's always positive. If they're opposites, it's negative. The next one's identifying numbers as integers or non-integers. An integer is just a fancy math word for a whole number that can be positive, negative, or it can be 0. Whole numbers technically are only positive. By definition, if I say a whole number, I'm only talking about positive numbers. That's why they use the word integer. Integer means they could be positive or negative, or it could be 0, but it can't have that decimal or fraction at the end. So 96.23 is not going to be an integer because it has that decimal at the end. 56/8. Well, if I divide 8 into 56, it's 7. 7 is a nice whole number, so yes, it is an integer. 37, hopefully you just look at that and say, yep, that's a whole number. Yes, that's an integer. 259.92, again, has that decimal at the end, not going to be a nice whole number. 13/9. If I divide 9 into 13, 9 goes into 13 once, but I have some left over. I have 4/9. So 1 4/9 is not a whole number, not going to be an integer. Number 8, if I have 17/7, 7 does not divide into 17 evenly, not going to be an integer. However, 5 divides into 25 5 whole times, so yes, that does simplify into an integer. 48.63 has the decimal on the end. It's not a nice whole number. It's not an integer. Negative 56 is a whole number, is an integer. Negative 30 is a whole number, is also an integer. Number 9. 45/9. 9 does divide into 45 5 times, nice and evenly. Yes, that is an integer. 57, nice whole number. It is an integer. Negative 64.54 has that decimal on the end, not going to be an integer. 3/7. Well, 7 doesn't divide into 3, so nope, it's not going to be an integer. And 714 and 77/100 again has the decimal on the end, not going to be an integer. So integer means you could have a positive whole number, a negative whole number, or it might be 0. 0 is still an integer. Rational or irrational numbers. Rational numbers, when you read that in the name of something, indicates that it's going to be a fraction problem. The definition of a rational number is anything you can write as a ratio of two numbers, where a ratio of two numbers is just like a fraction. 1 to 7, 1 over 7. So, when we're talking about rational numbers, we're writing about anything that can be written as a fraction. Well, if I can count fractions, I can also count mixed numbers, right? If I have 1 1/3, I can change that to 4/3 into a fraction. I can also count my whole numbers. If I have 3, I can put it as 3 over 1. I made it into a fraction. Well, if I can count my whole numbers, I can count things that are square roots that are perfect squares. The square root of 25 is 5, and I can then put it over 1 and make it into a fraction. I still have other things that are rational numbers. Terminating decimals. Well, what in the heck's a terminating decimal? A terminating decimal is one that ends, like 0.25. 0.25 we said was 25/100ths, and now I've just written it as a fraction. And the other kind of rational number you're going to have are repeating decimals. A repeating decimal, that 0.3333333333, although it's difficult or more difficult to change it into a fraction, hopefully you know it's a really common one. It happens to be the fraction 1/3. If you take 1 divided by 3 on your calculator, it's going to show 0.3333333333 on your calculator. So it's a repeating decimal. All of those things are included in your rational numbers. Irrational. Irrational numbers are non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals. An example of something that is irrational is the math symbol pi. Pi is the value you always get when you take the circumference of a circle divided by its diameter. Pi is, if you use your calculator and you hit Shift and the button that has the pi symbol above it, which says EXP, it's way down on the bottom of your calculator. So if you hit Shift EXP, you should see the pi button on your calculator. If you hit equals, you see you have 3.14159 ... and you get a decimal number that never ends and never starts repeating. So it doesn't go to 33333 or something like that on the end. It's non-terminating and non-repeating. So anytime you see something with pi, it's going to be irrational. The other way you're going to get an irrational number is to have a square root that is not perfect. If you did the square root of 2 on your calculator, you get 1 point ... and a whole bunch of numbers after that, and they don't stop and they don't repeat. So, only 2 ways you're going to get irrational numbers. What I would do is look at my list first and look to see if I have these 2 things. If they are there, they're irrational. If not, they're probably in this list on top. So I'm going to look and I say, oh, this one has pi in it. I know anything with pi is irrational. Then I've got a couple with square roots. Square root of 21. If I try to do the square root of 21 on my calculator, I'm going to get a big long decimal number. It's irrational. However, if I do the square root of 25, the square root of 25 on my calculator just gives me 5. 5 is a nice whole number. It's going to be rational. Now those were the only 2 things I had on my list. Pi and the square root of something that's not a perfect square. The rest should be on our other list. 26. 26 is a fraction. That's what a rational number is. 30.39 with the bar. The bar means it's repeating. Repeating decimals are rational. So if I look at number 11, same kind of thing. I'm going to look for my irrational ones first. Pi. This one here has pi in it. I know it's irrational. Then I look for my square roots. 16's a perfect square, but 11's not. If I do the square root of 11, I get a big, long, crazy decimal on my calculator. It's irrational. The rest, here's my square root that is a perfect square. I would get -4. Which is a nice whole number. This one's a fraction. We know all fractions are rational because that's what a rational number is. And then we have, again, a repeating decimal. Repeating decimals are rational. So I'm going to move the board. If you don't have this written down, pause the video for a minute. And then we're going to pick out our rational and irrational numbers on the next one. So again, I'm going to start with my irrational numbers. Irrational numbers, anything with pi. Here's something with pi. That's irrational. Square root of something that's not a perfect square. Again, the 11 is not a perfect square. If I do that on my calculator, I get a non-terminating, non-repeating decimal. I then look and I say, here's a square root, but it is a perfect square. That gives me -8 if I do it on my calculator. 8 is a whole number, which is rational. Here I have 28ths. 28ths is a fraction, which is what a rational number is. Here I have a terminating decimal. It ends. It doesn't keep going on forever. Terminating decimal I could write as -16 and 32 hundredths. So I can make that into a fraction. It is rational. So rational and irrational numbers. 13, 14, and 15, I'm adding fractions. Adding and subtracting fractions. When I add and subtract fractions, I have to have a common denominator, and I always want my denominator to be positive. So if there is a negative, I'm going to apply it to that top number. My common denominator here is 28. I then make my equivalent fractions. 4 goes into 28 7 times. I'm taking 7 times a -3, so that one's going to be -21. That minus sign stays in front there. Then I'm going to have plus 7 goes into 28 4 times. 4 times 4 is 16. Now I just do the work on the top of my fraction. I'm going to take negative 21 plus 16. Negative 21 plus 16 is negative 5. My denominator is 28ths. When I put that in on Alex, the negative will be in front of the fraction instead of on the top. Just like here we have negative 3/4. Our answer is negative 5/28. And of course you can use your fraction button on your calculator if you want to check that. The fraction button again is that one with the A, B, C. So you do negative 3 fraction 4 plus 4 fraction 7ths, hit equals, you should get negative 5/28. Of course, I'd prefer you work them on your paper, and on here I expect to see your work, and if you want to check them with your calculator, that's fine and dandy. When we're subtracting, same kind of thing. I have to have a common denominator. If I have 9 and 3, my least common multiple should be 9. If you happen to use 18, it's still going to work. You just have to make sure you reduce at the end. 9 goes into 9. 1 times 5 is 5. I get the minus in between. 3 goes into 9. 3 times 2 is 6. So I have 5 minus 6 on the top in the numerator of that fraction. 5 minus 6 is negative 1, so negative 1/9 is going to end up being my answer. And number 15, same kind of thing. I'm going to add my fractions. Since 4 does divide into 8 nice and evenly, 8's going to be my common denominator. 4 goes into 8 2 times. Negative 1 times 2 would be minus 2. A minus 2/8 is equal to negative 1/4. 8 goes into 8 one time. 1 times 5, still 5/8. There was that plus sign between them. So negative 2 plus 5, negative 2 plus 5 is 3. So 3/8 is going to end up being my answer. Again, it tells me to write my answer in simplest form, which doesn't mean to write mixed numbers, but does mean if I can reduce, divide those by the same things, I want to do that and put my answer in simplified form. We didn't have to do that on any of these. Then we get to some more complicated ones. When we have these ones, if there's a negative on the bottom, I'm going to rewrite it and put it with the top number instead of the bottom number. So I'm going to have negative 6/7 minus negative 9/5. Notice, I did not flip my fraction. All I did was put the negative with the top number instead of with the bottom number. So that when I write my common denominator of 35, it's a positive value. 7 goes into 35 5 times. 5 times negative 6 is negative 30. I have a subtraction in the middle. 5 goes into 35 7 times. 7 times negative 9 is a negative 63. Now they'll just put the parentheses there to separate the minus and the negative. So now we have to take negative 30 minus a negative 63. When we subtract a negative, we change it to adding. So we have negative 30 plus 63 over 35. Negative 30 plus 63, I subtract and take the sign of the larger, so we get 33 over 35. We can't reduce it down, so it is in simplified form. So throwing all those rules in for adding and subtracting, that subtracting a negative becomes a positive, and working our fractions out. So again, on number 17, there is a negative on the bottom. We're going to put it with the top number instead, so we're going to make the problem negative 5 over a positive 6 minus our 4/7. We then can find our common denominator, which is a positive 42. 6 goes into 42 7 times. 7 times negative 5 is negative 35. Minus 7 goes into 42 6 times. 6 times 4 is 24. We follow our rules for integers. They both have minus signs in front, so we add and keep the sign. we get negative 59 over 42. Again, that negative will be in front of your answer instead of on the top with the negative or with the 59. So negative 59 over 42. Number 18, same kind of thing. 9/5 plus 8 over negative 3. Since there's a negative in the bottom of the fraction, I got to put it up with the top number. 9/5 plus negative 8/3 then becomes my problem. My common denominator is then positive 15. 5 divides into 15 3 times. 3 times 9 is 27. Plus, 3 goes into 15 5 times negative 8, which is a minus 40. Again, they'll use the parentheses just to separate the positive and the negative sign, the plus and negative. But my rules, this is positive, this is negative. I subtract and take the sign of the larger one. So the larger one's going to give me negative. 40 minus 27 would be 13. So negative 13/15 is going to be my answer. Sign fraction multiplication. I'm thinking about my rules for multiplying and dividing, and it says that if I have a negative times a negative, it ends up being positive. So as a general rule, when you're just multiplying and dividing, if there is an even number of negative signs, I'm going to get a positive answer. So a negative times a negative makes a positive. If I have 4 negatives, I have a negative times a negative, which is positive, another negative times another negative, which is positive, and then I end up with a positive times a positive, which is positive. So if there's an even number of negative signs, it's positive. If there's an odd number of negative signs, then it's going to be a negative. So when I do these problems, unlike on the ALEKS program, I try to figure out the sign of my answer first, and then I worry about multiplying my fractions. I know that I have 1, 2 negative signs. I'm going to end up with a positive answer. I'm going to write it over there just to remind myself. Then I'm going to rewrite that problem without all those negatives in there, making sure I put my whole number over 1. So 2/9 times 8 over 1 times 3 over 5. Now I'm going to multiply my fractions. Keeping in mind I can reduce as long as the number's on the top and the bottom. I can't reduce the 2 with the 9, the 1, or the 5. Same thing with the 8, but the 3 I can reduce with the 9. 3 goes in here once and into here 3 times. I then multiply across the top. 2 times 8 is 16. Across the bottom, 3 times 5 is 15. My answer is positive, so 16/15 is going to be my answer. Again, we want the answer in simplest form, but not as a mixed number. So if you use your calculator to check it, it's going to give you the mixed number, 1 and 1/15, and then you hit the shift and the fraction button to change it into the improper fraction. Number 20, if I look at that one, I look and say, oh, there's 1, 2, 3 negative signs. Since there's 3 negative signs, I know my answer is going to be a negative. I'm then going to take 9 over 1 times 2 over 7 times 10 over 8. I'm then going to do some reducing. Well, I might do this. 10 over 8 I can reduce down. That's going to be 5 over 4. And then I look and say, oh, I can reduce that even more. 2 goes in here once and into here 2 times. And so now I can't do any more reducing. 9 times 5 is going to be 45. 7 times 2 is going to be 14. I know my answer has to be negative, so negative 45/14 is going to be my answer. Number 21. I've got 1, 2 negatives. I have 2 negatives. I know my answer is going to be positive. So I'm going to do 5/3 times 9/10 times 7/1. I can reduce the 5 and the 10. 5 goes into here once, into here 2 times. I can also reduce the 9 with the 3. 3 goes into there once and into here 3 times. So multiplying 3 times 7 is 21. 2 times all those ones is 2. I know my answer is going to be positive, so 21/2 is my answer. And then the last one, sign decimal addition and subtraction with 3 numbers. This is like what we did when we had 3 numbers with integers. They're going to start and do the pair with the same sign first. And then we add and keep the sign. So they're going to do these two first. 1.7 plus 2.1 gives me 3.8. Keeping my problem in order of how it is, I have -7 plus 3.8 then. So I think about my rules. I have to subtract and take the sign of the larger one. So I'm going to take my bigger number, oops, I don't need 2 zeros on the end of that, I just need 1, my bigger number, and subtract my smaller number, and I'm going to take the sign of the larger. So I'm going to subtract, and I'm going to get 3.2, the bigger one was negative, so -3.2 is going to be my answer. Number 23 happens to be that these two have the same sign in front. So I have to add and keep the sign. -12.8 and a -5.8. 16, carry my 1. 5, 6, 7, 8, 1. Negative. I have -18.6 when I add those together. So now I have 4 minus 18.6. Again, my rule is to subtract and take the sign of the larger one, but I'm going to take the bigger number and subtract the smaller one, so I'm going to get -14.6 when I subtract and take the sign of the larger number. The larger one was negative. And number 24, it doesn't want to let me move the board up any higher. I'm going to write that up here so you can see. It's -1.3 minus 6.4 plus 13. So again, they're going to take the two with the same sign first and add and keep the sign. -1.3 minus 6.4 would be -7.7. So now I have -7.7 plus 13. My rule, subtract and take the sign of the larger. So I'm going to take 13 and subtract the 7.7. Let's see, that'll make that 12 and 10, so 3 and 5. And the bigger one was positive, so 5.3 is going to be my answer. Now, yes, I know most of you probably on the assessment just grabbed your calculator and typed it in, so it's probably not going to be on your pie chart. But if you have to do it without a calculator, because you know that when I look at your homework pages, I look to see if your work is shown. You would have something written down there and you would have done it paper, pencil, and checked it with your calculator. And that is the end of our homework page.